Now, so last time we have solved question number 17. So write with me example number 18. An oil drop B has charge equal to 1.6 into 10 raised to minus 19 coulomb. So we are given information of oil drop. It has charge equal to 1.6 into 10 raised to minus 19 coulomb and mass equal to 1.6 into 10 raised to minus 14 kg. If the oil drop is in equilibrium, oil drop is in equilibrium means net force acting on the oil drop is 0. Net force acting on the oil drop is 0. What will be the potential difference between the plates? Potential difference between the plates is equal to question mark. The distance between the plates is 10 millimeter. The separation between the plates is given to be equal to 10 millimeter. Take the value of G equal to 10 meter per second square. So this is a plate, this is another plate. Reverse the polarities. Take this lower plate as positive plate and upper plate as negative plate. So between these two plates they have placed an oil drop. This oil drop is in equilibrium, means there will be zero net force acting on this oil drop. What will be the first force acting on this oil drop? Gravitational force. It has mass, so it will experience the gravitational force mg downward. So we have to balance this weight by creating the upward force. It has a positive charge also. It has a positive charge also. So this positive plate is going to repel it and this negative plate is going to attract it. Or in other language you can say this positive plate will create the electric field in this region. Also this negative plate will create the electric field. The positive plate will create the electric field away from it and negative electric field will produce the electric field towards it. So in short, in this region we will have upward electric field like this, away from positive and towards negative. So in this electric field you have placed a positive charge, and we know that positive charge experiences force in the direction of electric field and negative charge experiences force opposite to the electric field. Just like mass placed in the gravitational field experiences the gravitational force mg, similar to that charge placed in the electric field experiences electric force equal to QE, mg QE, or you can say EQ. So when a charge Q is placed in the electric field, it will experience the electric force EQ. Now these two shall balance each other. Only then the net force acting on the charge will be 0. Now we are not asked the electric field. See, we are given charge, mass and acceleration due to gravity, but we are not asked this electric field. What is asked? The potential difference. Now we have to figure out what is the potential difference between these two plates. Let us assume the potential difference between these two plates is delta V. We know the electric field is from higher potential to lower potential. Direction of electric field is always from higher potential to lower potential. So this plate will be at higher potential, this plate will be at lower potential. They have given us the separation between the plates. What is that separation? Small d, 10 millimeter. Now we will assume that the electric field in this region is uniform, means at all the points it is at all the points it has same magnitude and same direction. We will assume that the electric field at all the points has same magnitude and same direction. And by assuming the electric field to be uniform, you can directly write the formula for magnitude of electric field is equal to potential difference upon distance. Just for sake of number, magnitude, potential difference upon distance, or you can see here. Potential difference upon perpendicular difference, potential difference between the equipotential surfaces upon the perpendicular distance. This can be used if electric field is uniform. This is applicable only for uniform electric field. So we are talking about this relation. So this is the equipotential surface. At all points, let's say potential is V1. At all these points, let's say potential is V2. So these two are equipotential surfaces. This is first equipotential surface, this is second equipotential surface, and the perpendicular distance between is, let us say, d. So I can write electric field as potential difference upon distance, assuming that electric field is uniform, is equal to what? mg. Now clearly you know all these things, and now you can figure out the potential difference between the plates. Write down. So it is mgd upon q. Mass is equal to 1.6 into 10 raised to minus 14 kilogram. Value of G is 10. Value of G is 10. D value is 10 millimeter. So 10 into 10 raised to minus 3. Whenever you do replacement, put the bracket. Charge value is 1.6 into 10 raised to minus 19. One point six cancel, minus 14 minus 19 plus 5 plus 5 plus 6 plus 7 minus 3, that will be plus 4. 10 raised to 4 volt is the potential difference. Next question, example number 19. Some equipotential surfaces are shown in the figure. What is the correct order of electric field intensity? Example number 19. You are shown with the equipotential surfaces. We are given equipotential surfaces, and we have to figure out correct order of electric field. Equipotential surfaces are shown. We have to figure out correct order of electric field. Correct order of electric field. Write down. So these are the equipotential surfaces. Like this. Here we have point A. Here we have point C. And here we have point B. These are not electric field lines. These are equipotential surfaces. Now you can remember this as a rule. Similar to electric field lines. If electric field lines are crowded, magnitude of electric field is more. And if electric field lines are not crowded, magnitude of electric field is less. Similar to that, write down, if equipotential surfaces are crowded, then magnitude of electric field at that point or in that region is more. Magnitude of electric field in that region would be more or will be more. So with that logic, at point B they are most crowded. In a region around B they are most crowded. So you can see magnitude of electric field at B is highest. Then at point A they are least crowded. Around point A they are least crowded. So A will be the last. So in between you will have C. Now at point A, direction of electric field, you know electric field and equipotential surfaces are perpendicular to each other. So here you show the direction of electric field also somewhat perpendicular to the equipotential surface. At point C also show the direction of electric field somewhat, or it should be perpendicular to equipotential surface. At point B it would be like this. You should know that electric field and equipotential surface are always perpendicular to each other. Of course you cannot compare directions, you have to compare only magnitudes. Any doubt in this question? Okay, write down with me next concept, electric dipole. Next point is electric dipole. Underline, a system of two equal and opposite charges separated by small distance is called as electric dipole. a system of equal and opposite charges separated by small distance is called as an electric dipole. Underline that. So show this minus q, show this plus q. Let's say they are separated by the small distance. This is the small distance between them. Every dipole, underline, every dipole has a characteristic property called as dipole moment. For every dipole, we are going to calculate dipole moment, electric dipole moment, or simply you can say dipole moment. Underline, it is defined as product of magnitude of either charge and separation between the charges. Underline, dipole moment is a vector quantity and conventionally its direction is from negative pole to positive pole. Okay, all these things are important. So draw this electric dipole. Electric dipole means two equal and opposite charges separated by finite distance. Let us mark the center of the dipole. Let us mark the center of the dipole. Now let us say center to minus q distance is small l and center to plus q distance is also small m. Then what will be the total separation between the charges? 2l. This is also called as length of the dipole. 2l is called as length of the dipole, or you can directly take capital L. The small l are length of the half length of the dipoles, half lengths of the dipole, and this 2l is the total length of the dipole. Now people will define dipole moment. Dipole moment symbol is small p. It is a vector quantity. Its magnitude is given as product of magnitude of one of the charges. Out of two charges, you have to write any one charge multiplied by separation between them. One of the charges into separation between them. This is the formula for electric dipole moment, Q into 2L. The direction, this is magnitude. Direction is from negative charge. Direction is from negative charge to positive charge. Direction is from negative charge to positive charge. So you can show this as an electric dipole. This arrow is taken as electric dipole P bar. Its direction is from negative charge to positive charge. This is a vector electric dipole moment. What is the magnitude of the electric dipole moment? One of the charges into separation between them, and direction is from negative charge to positive charge. What is the unit of electric dipole? Write down. What is the unit of electric dipole? Unit of charge multiplied by unit of separation. Charge unit coulomb and separation means meter. So it is coulomb meter. Don't write small c. If you write small c, you will read it as centimeter. No, it is not centimeter, it is coulomb meter. This is unit of electric dipole moment, coulomb meter. Now find out the dimensions of electric dipole moment. Find out the dimensions of electric dipole moment. How will you find dimensions? First, find the unit in terms of fundamental units. Coulomb is not fundamental. Coulomb is not fundamental. So how to convert coulomb? Ampere into second. Charge equal to current into time. And into meter as it is. So you can write this as kg raised to 0 meter raised to 1, second raised to 1, ampere raised to 1. This is the unit of dipole moment. So what are the dimensions of dipole moment? Mass raised to 0, length raised to 1, time raised to 1. For ampere you can write I or letter A as it is. So this is how you shall be able to find out unit and dimension of electric dipole moment. Clear? Next point. Write down the next heading. Electric field intensity. झालं का नाही? Next point is electric field intensity at a point on the axis of electric dipole. Electric field intensity due to dipole, or simply write electric field due to dipole. First heading is at a point on the axis of the dipole. At a point on the axis of the dipole. So let us say this is minus q, this is plus q, this is center of the dipole, this is half length of the dipole. Draw with me. This is remaining half length of the dipole. This line which is passing through both the charges is known as axis of the dipole. This line passing through both the charges is known as axis of the dipole. This line is axis of the dipole. Now we have to choose any general point on the axis of the dipole, and at that point we have to find the electric field. Now all the distances are measured from center of the dipole. So we will assume at any general separation, let us say this separation is equal to small r. We choose a point, any general point. At this point we want to figure out what is the electric field. So at this point the positive charge will produce the electric field away from it. E plus means what? Electric field produced by the positive charge. And this negative charge will also produce its electric field at this point. It will be towards it. Positive charge produces electric field away from it. Negative charge produces electric field towards it. So this will be called as E minus. E plus and E minus are just numbers. The arrows take care of direction. The net electric field will be what? Who will win? E plus will win or E minus will win? Electric field due to positive charge will win, because charges are equal in magnitude, but positive charge is closer to this given point. Any general point, we can call that any general point at Z. At point Z we have to figure out the electric field. So at this point the net electric field will be in the direction of E plus. So these two will give us resultant electric field at this point as rightward. So this is your net electric field. You will call that as E axial or E axis. Electric field at a point on the axis. You can write magnitude of electric field at a point on the axis is equal to magnitude will be subtraction of these two numbers or addition of these two numbers or Pythagoras or parallelogram. These two vectors are opposite to each other. So subtract their magnitudes, you will get magnitude of the resultant. Now what is magnitude of electric field produced by the positive charge at a given point? For that you need this distance. What will be this distance? R minus L. This distance you can write as small r minus L. What will be the electric field due to this positive charge? Point charge produces electric field kq by r square. K is k, q is q. R is what? R minus L. So R minus L bracket square. This is the magnitude of electric field because of positive charge. Minus electric field due to negative charge. It will be also kq upon r square. We have to write magnitude. So k is k. Q is not minus q. You are finding magnitude. Magnitude of electric field due to minus q. So k is k, q is q. Don't put minus q here. Upon r square. For r, you need this total distance. What will be this total distance? R plus L. This distance would be how much? R plus L. Not R plus 2L. It is simply R plus L. R is distance from the center. So here you will write R plus L bracket square. Now to solve this further, what we can do is this. Electric field at a point on the axis of an electric dipole is equal to kq outside derivative, not derivative, outside bracket, 1 upon r minus L bracket square minus 1 upon r plus L bracket square. Do the cross multiplication. R plus L bracket square minus r minus L bracket square divided by multiplication of these two. Write down. Divided by multiplication of r minus L and r plus L. R minus L square into r plus L square. So kq in the bracket. Now when you solve this square, when you expand this square, r square minus r square will get cancelled. L square minus L square will also get cancelled. But this 2rl minus in the bracket, expansion of this square is minus 2rl. A plus b bracket square, a minus b bracket square. A square plus 2ab plus b square. A square minus 2ab plus b square. A square b square, a square b square cancel by subtraction. But 2ab and 2ab get added. Divided by. You can treat this bracket as a and this bracket as b. A square into b square is ab bracket square. So you can combine these two brackets, r minus L into r plus L, and create a new bracket square. And now you get the final answer kq. This 2rl minus 2rl is 4rl. This is what? R minus L into R plus L. A minus B into A plus B is A square minus B square. So R minus L into R plus L is what? R square minus L square, but this is again whole bracket square. This is basically the final answer, but people rearrange this as K, Q Q, this 4 can be written as 2, this L as it is, and this R as it is. 4 can be written as 2 into 2. Basically this is 4RL. This entire thing is 4RL. But 4RL is written as 2L into 2R. 4RL is written as 2L into 2R. Now you will put bracket here, divided by R square minus L square, bracket square. What is this Q into 2L? One of the charge into separation between them is what? Electric dipole moment. So K, P, 2R, Q into 2L is what? Dipole moment P. This Q into 2L is dipole moment P upon R square minus L square, bracket square. Now we will rearrange this as K 2PR upon R square minus L square, bracket square. This is the magnitude of electric field at a point on the axis of electric dipole. K 2PR upon upon R square minus L square, bracket square. This is the magnitude of electric field at a point on the axis of the electric dipole. K 2PR upon R square minus L square, bracket square. K 2PR upon R square minus L square, bracket square. Now let us figure out the direction of electric field. Let us draw here electric dipole moment vector P bar. This is electric dipole moment vector P bar. What is its direction? Negative to positive. What is the direction of electric field at a point on the axis? Same as the dipole moment. You can check the direction of dipole moment and the direction of electric field at a point on the axis. Both are identical. So you can convert this relation into vector form. How will you convert this relation into vector form? Direction of electric field E bar is exactly same as P bar. So you can just convert this P into P bar and E into E bar. Because both of them have same directions. You can create same directions on left side as well as right side. So finally, let us write the vector form as well. Write down the vector form. E bar is equal to K 2PR, but P will be converted to P bar upon R square minus L square, bracket square. So this is our vector form. Electric field at a point on the axis will be in the same direction of the dipole moment. Electric field at a point on the axis will be in the same direction as that of the dipole moment. ऍक्सिस वरची इलेक्ट्रिक फील्ड डायपोल मोमेंटच्या डायरेक्शन मध्ये असते. द फील्ड ॲट अ पॉइंट ऑन द ऍक्सिस is in the same direction as that of the dipole moment. झालं. नेक्स्ट हेडिंग, इलेक्ट्रिक फील्ड ऍक्सिस वरची झाली. नाउ वी विल फाइंड इलेक्ट्रिक फील्ड at a point on the equator of the dipole. At a point on the axis, now we will find electric field at a point on equator of the dipole. So observe the diagram carefully. Leave some space here. Let's say this is minus q. Draw with me. Let us say this is plus q. This is the separation between them. Let's say this is the center of the dipole. Let's say this is half length L. Let us say this is remaining half length L. Total length will be 2L. Now this central line, which is perpendicular to axis of the dipole, this horizontal line passing through two charges, this line passing through two charges is the axis, but line passing through center and perpendicular to axis is called as equator of the dipole. This line is called as equator of the dipole. Choose any point on the equator of the dipole. At this point we want to find out the electric field. All the distances are measured from the center of the dipole. Let us take this any general point as Z. Let us take this any general point as Z. Let us take this distance of point Z from the center of the dipole as small r. We will take distance of given point from the center of the dipole as small r. Now at point Z, the positive charge will produce its electric field, as well as negative charge will produce its electric field. Both positive and negative charges will produce their electric fields at point Z. Write down. This positive charge will produce the electric field away from it. The positive charge will produce the electric field away from it, and the negative charge will produce the electric field towards it. Positive charge will produce the electric field away from it, and negative charge will produce the electric field towards it. Now these two electric fields are not in same direction. You cannot directly add them. They are not in opposite direction. You cannot directly subtract them. You also don't know what is angle between them. They are not at 90 degree. You don't know this angle. So you have to resolve these two electric fields. You have to check which components get added, which components get subtracted. So what you have to do is this. Okay, before that, if this is the electric dipole, then draw the electric dipole moment vector. It is directed from negative to positive. You can show it here also directly. इथे जरी असं दाखवला electric dipole moment तरी चालेल, or better show it outside. This is electric dipole moment p bar vector. It is directed from negative to positive. Now this positive charge will produce the electric field away from it. Negative charge will produce the electric field towards it. Let us take this oblique distance as small d, and this oblique distance is also what? Small d. Now how much electric field will be created by the positive charge? At this point, how much electric field will be created by the positive charge? It is kq by r square. K is k, q is q, r square is what? D square, and d square is what? D square is what? R square plus L square by Pythagoras. This is R and this is L. So this is what? R square plus L square. Similarly, what is E minus? Electric field produced by the negative charge. Again it is KQ by R square. K is K, Q is Q. Don't put Q as minus Q. Here you are finding magnitude of the electric field. This arrow is taking care of direction. You are not finding potential. If you are finding potential, then charge is to be put with sign. But here you are finding magnitude of electric field. This not over. Where? Over. Don't put this Q as minus Q. You are finding magnitude of the vector. So K Q by R square. K is K. Q is not minus Q. Put Q as Q. R square is what? R square is D square. So it is K Q upon. What is this D square? Again the same thing. It is R square plus L square. Write down. It is R square plus L square. So these two electric fields are basically identical. These two electric fields are basically identical in magnitude. Magnitude of E plus is exactly equal to magnitude of E minus. Electric field produced by the positive charge is exactly equal to electric field produced by the negative charge. But we don't want what is relation between them. We want what is the net field because of them. So we will choose this angle equal to theta. Now choose the axis. These are the vectors. Draw the vectors. Choose the axis. Resolve the vectors. Check which components get added, which components get subtracted. Find resultant in x, resultant in y, and then finally use the Pythagoras theorem. If this angle is theta, this angle would also be theta. If this angle is theta, this is isosceles triangle, so this has to be again theta. This angle is also theta. If this angle is theta, you can check. This is a straight line and these two lines are parallel lines. So these corresponding angles. This is theta, this also be theta. हे दोघं पण काय असतील? Thetas असतील. Now this E plus can be resolved as E plus cos theta, and this up component will be E plus sin theta. Same goes with this E minus. This is what? E minus cos theta. And this down component is E minus sin theta. Now obviously the diagram will look complex, so it's always better to draw the bigger diagrams. काय केले लक्षात आलं का बघा? After resolution of the vectors, we get this. मध्ये नसेल दाखवायचं नका दाखवू. You can draw the situation separately. You can redraw the situation. This is what? E plus. This is what? E minus. This is E plus. This is E minus. Here you have two components. This is what? E plus cos theta. This is E minus cos theta. Show this separately. Write down. This component will be E plus sin theta, and this will be E minus sin theta. Now the resultant will be what? The resultant, the net electric field at that point, name that point as Z. At point Z, net electric field is E plus and E minus are identical. So 2 times E plus cos theta, and E plus sin and E minus sin will cancel each other. So this is your net electric field at a point on equator. This is the net electric field at a point on the equator. जी net electric field येणार कशी येणार का बघा. This E plus and E minus will add and will give you net electric field at a point on the equator. Write down. Therefore, net electric field at a point on the equator is 2 times E plus cos theta. 2 times E plus cos theta. And now you already know what is the value of E plus. Put the value of E plus and put the value of cos theta. You will get the final answer. Put the value of E plus and put the value of cos theta. You will get the final answer. What is the value of E plus? The value of E plus is kq upon r square plus l square. The value of E plus is kq upon r square plus l square. Put that value. 2 times k q upon r square plus l square. And what about cos theta? What is cos theta here? Adjacent. What is adjacent? L. And what is hypotenuse? D. And how to replace D? Under root r square plus l square. This is q into 2 into l. Q into 2 into l is what? Q into 2l is what? Dipole moment. K as it is. Q into 2 into l means what? Q into 2 into l. Q into 2l is dipole moment. This is what? R square plus l square bracket raised to 1. And this is what? R square plus l square bracket raised to 1 by 2. So 1 plus 1 by 2 is 3 by 2. X into root x. This is in the format of x into root x. X into root x is x raised to 3 by 2. So this will be what? R square plus L square bracket raised to 3 by 2. So this is the formula for electric field at a point on the equator. This is the formula for electric field at a point on the equator. And finally, you can write this in the vector form also. Finally, you can write this in the vector form also. You can check direction of electric field at a point on the equator is opposite to the dipole moment. Dipole moment is from negative to positive. Dipole moment is from negative to positive. But field at the equator is from positive to negative. So these two vectors are basically this electric field at the equator. Check its arrow and arrow of the dipole moment. They are opposite to each other. So this is what? Minus k into p bar. Means p bar and e bar are not having same direction. The minus sign says that direction of p bar is to be reversed to get the direction of e bar. Direction of p bar is to be reversed to get the direction of p bar. So minus k p bar upon r square plus l square bracket raised to 3 by 2. This is the vector form. Next, so these are the electric fields at a point on equator and at a point on the axis of an electric dipole. Now sometimes we have a case of a spatial dipole. That spatial dipole is called as short dipole. Write down. Next heading as electric field due to short dipole. Now let us first understand what is the short dipole. Let us first understand what is short dipole. Let us say this is minus q, this is plus q, and this is the separation. You can directly take the separation as capital L or 2 times L. This 2L is very small. Length of dipole, write down. Length of dipole is equal to 2L. If it is very small compared with length of dipole 2L, if it is very small compared with distance of given point from the center of the dipole, distance of given point from center of dipole, then dipole is termed as short dipole. When the dipole is termed as short dipole. Short dipole is the dipole whose length, that is separation between the charges, is very small compared with the distance of given point from the center of the dipole. You can take this as given point Z. Distance of given point from the center of the dipole, you can take this as R. And you can say this distance R, that is distance of given point from the center of the dipole, is very large. If it is very large, compared with the length of the dipole, then your dipole becomes short dipole. Now you know when to call a dipole as a short dipole. Now electric field due to short dipole. First heading, at a point on axis, at a point on axis of the dipole, at a point on the axis of dipole. So this is minus q, this is plus q, and this line Write down, is the axis of the dipole. Let us take length of the dipole as 2L, center of the dipole as C, any general point Z. At that point we will have the electric field at a point on the axis. This is the dipole moment vector P bar. It is directed from negative to positive, and this is axial electric field E or E bar, you can say. What is magnitude of electric field at a point on the axis due to long dipole? Due to long dipole it is K 2pr upon r square minus L square bracket square. We derived this on the previous slides. But here we have the short dipole. For short dipole, the separation between center to given point we know what is short dipole. Electric field due to short dipole at a point on axis, at a point on axis of the dipole. So let us say this is minus q, this is plus q. This line will be taken as axis of the dipole. This is any general point Z. This is center of the dipole. This is half length L. This is remaining half length L. This is dipole moment vector P bar, negative to positive. This is distance of any general point Z from the center of the dipole at a point on axis. We know the direction of electric field at a point on axis and the dipole moment is same. For long dipole, what is the formula for electric field at a point on the axis of long dipole? It is K 2pr upon r square minus L square bracket square. But here we have short dipole, so this r is very greater than length of dipole. Distance between given point and center of dipole, this is short dipole, so this qn small minus qn plus q are at very small distance. This 2l is very small compared with the distance r. So if r is very large than 2l, can I say r is very large than l, or r square is very large than L square? If r is much greater than 2L, r will be much greater than L, so r square will be much greater than L square. So what will be this addition? R square minus L square can be approximately taken as r square. Therefore, electric field at a point on the axis of the short dipole is approximately equal to K 2pr upon r square minus L square is what? It is r square. R square bracket square is what? R raised to 4. So what is the final formula for electric field at a point on the axis? K 2p upon r cube. This is the formula for electric field at a point on axis of short dipole. What will be the vector form? Field at a point on the axis is approximately kp by r cube, but its direction is same as dipole moment vector. So E bar P bar are in same direction. E bar P bar are in same direction. So this is the formula for electric field at a point on axis of short dipole, K 2p by r cube or Kp by r cube. झालं? होमवर्क लिहा. Resolve. Solved example 1 to 19, chapter electric potential. इलेक्ट्रिक फील्ड ची लिस्ट ऑफ फॉर्म्युले केली आहे का आपण? केली आहे का? इलेक्ट्रिक फील्ड ची केली आहे का नाही बघा. केली नसेल तर करावी लागेल. टेस्ट त्याच्यावरतीच आहे ना. 1 to 19 सॉल्व्ड एक्झाम्पल्स करायचे आणि सेपरेट पेज वरती केली नसेल तर करायचे. लिस्ट ऑफ फॉर्म्युले कुठल्या चॅप्टरची? इलेक्ट्रिक फील्ड याच्या आधीचा चॅप्टर. ठीक आहे. ही दोन कामं आज करायची आहेत. ही आज व्हायलाच पाहिजे दोन्ही कामं. उद्यापासून आज लास्ट पेपर आहे ना. उद्यापासून तुम्हाला रेग्युलर होमवर्क पण मिळायला चालू होईल. सॉल्व्ड एक्झाम्पल, क्वेश्चन सेट, नीट PYQ, JEE PYQ. ठीक आहे. तो करायचाच आहे. चालेल, थांबू. बसा. लिहून होते ना माझ्या बरोबर का पास होते? लिहून होते. पास झालं, थोडंफार राहिलं तर नंतर घरी जाऊन नोट मध्ये बघून लिहिता येईल. सगळ्या नोट्स आहेत का? अप टू डेट आहेत का? नोट्स अपलोड केल्यात का? लिंक वरती सगळे नोट्स, सगळे लेक्चर्स पण आहेत. काय मिस झालं असेल कोणाचं, टेस्ट मुळे बुडवलेलं असेल तर ते कंप्लीट करून यायचं उद्या.